可以录了。
Yes, start.
To all my friends, the night is young, the music's loud, they're playing our song. Nowhere else that I belong than here with you, than here with you. I remember this night got started when you entered. I hope we can get a little closer, maybe even get to know your name. I wanna hear the music so loud. Get some drinks inside me right now. So baby, let it go. You had me at hello. Let's raise our glass and toast. DJ, play that one more. To all my we know it. If you got some money, time to blow it. Cause the way you got me feeling so sick. Dance to the night.
Okay.
Start.
We'll start. Okay. Good. Today I will spend one night to talk about parallel programming. So how to use this parallel. Okay. We try to design C programming use parallel. Okay. So this is the first and easiest step to help you to jump into the parallel computing. Okay. There are several others. Okay. Currently we have MPI is another parallel language. You can include it in your C program. Okay. And also we have currently, you remember, big data, cloud computing is very famous, right?
Yeah.
Basically it's parallel computing. We call MapReduce. Even the database is parallel. So today we're learning, this is the simplest way, and even your freshmen know how to do this. Okay? And this is the simplest way. So every computer nowadays is multi-core. Basically, it's several processors inside your CPU. So if you write your code, if you are not take advantage of this multi-core, then it is a serial program. So then we can add this OpenMP. Then your code will become parallel. Okay. So what is? Okay. So it basically is take advantage of the multi-core, okay, and try to your C program become multi-core at the same time. So normally, for example, your desktop on your laptop, maybe you have 2 or 4, even better 8. So currently,
Shouldn't be 4 cores.
huh?
Generally, it's 4 cores.
Generally, that's because you i5. Because i7, maybe you have 8 cores. The server side the CPU have 16 cores or even 32 cores. Okay, so supercomputer, each CPU have 32 cores. Okay, and in this case, each CPU can calculate 32 at the same time. Okay. So in this case, we will use the cluster machine. Definitely, we will use multi-cores, and that the previous several years ago is like 8 cores or 16 cores. Now we have even 32 core CPU. So okay, then how to use this CPU to take advantage of this multi-cores? Okay, there are several ways to write a program. Okay, you can write a program like use some parallel, use MP API or some parallel programs, and use parallel program compilers, and then you create a parallel code and run it, and you can use this multi-cores. Or other way we will use today, we'll talk about how to use OpenMP to change your code to become a parallel. And basically, this OpenMP is included in Visual Studio, okay, since Visual Studio 2008. So right now, if you install Visual Studio 2008 or 2010, 2013, already have OpenMP technology inside. Because you don't know. You don't know how to use this. Okay? So today I will tell you how to use this. Okay? Very simple API. This is another API. Parallel API. Include OMP.h in your code. Your code is already ready for parallel. The only analysis is how to use this. Okay? So basically, you need an include file. First, you need some kind of, okay, we call OpenMP derivatives, or you call pragmas. So starting from sharp pragma, then OMP, then here you need some kind of we call derivatives. Okay, derivatives here, then the remaining code will become parallel. Okay, you don't need to change the code. Okay, and it automatically will create, compile to become a parallel code. So this is amazing. Okay? So for example, originally you have a code. Okay? This code is we call sequential code. Currently all the code is sequential. For example, you define, you do some for loop, right? This is currently you write this code. Now if you add this include, add one line here. You say pragma OMP parallel for. For means this for loop will become parallel. Now if we go code going to here, all this part, your for processor will share this part. Do one thing. How? You I is equal to start 0, I less than n. If n is 1000, you will divide it by 4. Each one do part of it. And they can amazingly they can work together, and you will eventually get the right results. Okay? So see, very simple.
Is this a program OMP parallel for its syntax or?
Yeah, this is we call derivative, OpenMP derivative. So it's like go back to. So we call OpenMP compiler derivatives. Okay. So you only need add one line. This line only this include can understand.
If I don't add this line.
If you don't add this line, just have this still sequential code. But you add this line, it will become parallel. Only this part is parallel. Okay? Not this part. Okay? This is still sequential. This you don't need parallel because this is nothing. It's just an error. Right?
Is this line the constant, or can I change it to another way? Or
of course.
No, I mean this program parallel for.
Yeah.
Is this?
There are many different statements here. Not just one. Okay, I will teach you
They are
today.
different.
Yes.
But
We'll handle many different ways, situations you need. Okay?
another
just one.
question is how to end this parallel. For example, I run.
Once the function is end.
Oh.
Yeah, the parallel will stop.
If
So,
I only a part of the program.
that's exactly this OpenMP works. So let me show you how this works. Okay? OpenMP is amazing. Okay? So basically they try to turn this single program, we call single program, but multiple data, this model. Okay? Your program is one program, but your data may be multiple data in the parallel. Okay? So they will share this, we call shared data. So for example, your data is, now originally is this data, right? The code. And we will use, for example, you have 4 core. It will create 4 threads. Okay? Because that line, one line. They will become 4 threads. If you check your Windows process task manager, you will see 4 processes were created. And then each one do part of the job. Okay, this is starting and ending will differently. They will share the burden. Okay, share this part calculation. You calculate this part. I calculate this part. This part. This part. Okay, see. So if this is a big loop, then it will be 4 processors doing this at the same time. So it's much better and easy for your code. Okay, you don't need. So this we call single program, a multiple data model. Okay, the thread will doing some of the part you want to parallel, just one line, done. See? And this you guys should know, and then your code will run much faster. Okay? Okay, now we will teach you a little bit of this. Okay? For example, you have two for loops, right? You can, this part I want parallel. This part I don't want. Okay? This part I want, then you just, each part, you just add a line. This is the for, then you add this line. Okay? Then this becomes sequential, this parallel. You see how this works? So, this OpenMP is amazing, but it's a simple parallel program. Okay? We call fork and join model. What is fork and join model means? Originally it's single, so it's one processor doing. Going to here become 4. This is 4. So your task will create 4 processors. How you create in the C programming? You will create another thread, right? In this case, this will tell you it automatically creates thread for you. Just this pragma. They will done. And how many threads? It depends on your machine. Okay? Once the finish, it will we call join. Join, we can this 4 thread will sleep. Okay, and this become 1 thread. Then it becomes another thread, 4 thread, and then it becomes 1 thread. This is all fork and join, fork and join. Okay? The problem is here, because we have 4. This creates. Well, do I need like delete this 4 thread and then create another thread? No, they were very smart. This is 4 thread started. When finished, just sleep. Okay, you don't do anything because you said I don't need. Okay, and now we start again.
So start again or
start again.
A new create a
no,
new?
I think it will not create new because if you create new, it's stupid. Okay, in this code, in your whole code, compile this code. They know this part I need, this part I need. It will keep this thread, and then it just doesn't do anything. Okay, now doing. Here you're doing. So it's fork and join, fork and join. Okay? So it's very interesting.
Like you shut down the first part and start the second part.
Yeah, let me, yes. Oh, this one. I didn't put this. That's why I cannot control. So the OpenMP is very, very good technology. Okay. So first, this part is a serial. We call sequential. Now become parallel. See? Because of this line. This part will become parallel. Then how many threads? Each line represents 1 thread. How many threads? Depend on your machine. Your machine is a powerful CPU. It will create more threads. You have 8 core, it will become 8. 16, it will be 16. If you only have 2 dual core, it become 2. Right? My machine, this machine is 4. It will create 4. Okay? You will see 4 threads will create it and do this job. If this is, for example, 10,000, it will divide by 4, and each one will evenly do this job. Okay? And this is the same thing. Now we'll fork again, join again, become a serial code, and become a parallel, and then become a serial. See? Then you're wondering what this range should be. This range is normally is 1 statement, or you can use parentheses, a bracket. Okay, we call bracket. Okay, tell this block I need parallel, not this one. Okay, because this I don't add a block, add a parentheses. Okay, then in this case it's just this line. Okay? This is just this line. Okay, sometimes you have multiple lines. It's bigger, even multiple, so that's also okay. Okay. So in OpenMP, so it's very simple. Okay, so you can tell which part you want to parallel. So we call parallel range. You just tell which parallel you need. Okay? And normally we were using, for example, for loop, do while loop, all this intensive calculation. That part you need parallel. If some you don't need parallel. For example, input output, you just get something from your keyboard. That's you don't need parallel because the parallel cannot help anything, right? For example, you print something, output, and that become so. Normally, it's heavily doing something, intensively doing something. We need parallel. Okay? So, but what data? Data is what we call shell. Okay? The data is a shell because it's in the same process. So we call shelled data and the different thread. This is a multi-thread. Okay? And okay, there's several kind of techniques we will talk about this today. Okay? What is? Okay, now this is what I talk about. So this part is parallel. Okay, so you use this bracket and tell I want this part. OpenMP, I want to use parallel to do this part. What this part? This will do a big job. It's busy. Do something. You need this. Okay, and the keys for this. Okay. So this we call what is this structure block for this. This have a problem. This we call not a structure block because you have go to outside. This is not good. Don't do this. Okay? Because you do something you based on some condition you want to go out, then this is not good. Okay? It's not a constructive block. The better is okay, what is? Okay, you go to more, but this more is here, right?
Yeah.
So this is okay. Looping or something. This is okay, but don't go outside. Go outside is how to assign the jobs, right? It's complicated to do the use multi-thread different program to do this job. Okay? So we want the structure block, okay, and make that part to parallel. Okay? So normally we will use this to represent this is the part we want to parallel. Or you just like this. This is also okay. Okay, this is just one statement, but this is also okay. Okay, okay. This is called parallel region, right? For example, this code. This is parallel region. Okay, and this is parallel. We OpenMP have several functions. This is a library, so they have several functions. For example, this. I can find out how many threads or how many cores in your CPU, in your computer. This have a function like OMP get thread number.
Virtual core or real core?
Huh?
Virtual core or real core?
One real core.
Real. They have virtual core sometimes.
Virtual core. I think it's virtual core. It's just, if you dual core 2, if it's some other, it will give you the numbers.
I think they use the set number string, so they
Also set, this is set
so
number.
they are virtual.
Set number of
Yes.
threads, but this is maybe the set list, right?
Yeah.
Well, this if you only have 2, this is not working. I think. Okay, you can try. I don't think it will work. It should be you have how many threads, and it's better less than or equal to your computer. How many threads? Not normally we will get how many threads. Okay, there are several functions to help you decide. Okay, what this? Put a parallel at the work shell on the same line. What this mean? Oh, you can do like this. You can normally just like this. Okay, don't do like parallel and then you say OMP4. This works, but this is just waste your time. So just like this is even better. Okay, put the parallel and the work shell on the same line. Shell work shell. This time we shell 4. Okay, they know all these 4 statements will create a couple of threads doing this. Okay, because this is a huge job. Okay, the function take a lot of time and a lot of calculations, and they use the parallel to calculate. Okay. If we don't have the OpenMP, then how to write? Though the code will be more complicated, right? You need to create how you create in Java. You know how to create a thread. You need to create a thread, but even you create 4 threads, how to distinguish this task to each thread? Imagine you complicate,
Yes.
right?
And
It's
Java virtual machine
Yeah.
use the
Yeah.
virtual thread.
virtual thread, right?
Yeah,
Yeah.
not.
But how do you use this? Definitely,
Yeah.
this is simple,
This is
Yeah.
better, much.
right? This is much simpler and easier.
If it can access the
Yeah.
physical core, it's much.
Yeah.
it's much-
So some language, if you try to use parallel, the code is very fast to write. If you are not using this, I try to write a program like a multi-threading. Then you need to think of like you create a couple of threads. The problem you can create more threads, but that thread is not individually to the dual core. I mean the core. The problem is you need maybe you have some deadlock. You need to handle this. Okay? In different thread, if you're doing something, you may have deadlocks. Okay? So basically, this model is we call shared memory model. Okay? So this is your code, your data. Data is shared by all the threads surrounding this data. So they know the data, your data, and then this thread will working together. And thread, of course, they can have their own private data. Okay? Okay, each maybe have their private data. They are not shared this data. Okay? But the shared data eventually unique. Okay? Because your results is in the shared data. Okay? Everyone can access this, but each thread only work part of it. And then eventually you got the value. Okay? So today we have some exercise and like the code. Then you can see how it works together to create to do one job. Okay? So data can be shared by the thread, or thread can also have some private data. Okay? So this is a shared memory model. Okay? What's this? Okay, this just tell you a little more what is the shared memory data. Okay? So shared because the global variables, all this is shared among all the threads, but not everything is shared. Some is a private. Okay? Some data is private for some like thread. Okay, now we will talk about this. What is the private? What is the hardest part is here. You have a code. For example, this. This is some. I want to add something together. Okay. Now the problem is if you this part, four part, you want to parallel. What happens? Each one do part of it, right? They starting from 0. So how to count this? You want to add this thread add become 10, and that thread add become 20, that becomes 30. Eventually this 4 should add together. Otherwise the value is not right. Each one is only part of the L sum, right?
Yes.
Okay, so that's we call this is a critical section. Okay, so you need some kind of to tell the parallel. I need you sum this value together. I need that value. I'm not use each one got a value, and I'm not interested in your part of the value. I want to we call reduce. This is map reduce or some kind of parallel programming have these issues because each thread calculates a part of the value. And I want reduce. Reduce means all these values will add together. Add together, eventually I got the sum. Okay? Because we want to add each thread. Each one got LSUM, right? And add together. This is the sum we are interested in. Okay? So thread web turns only one thread at a time execute this critical section. Add to this, add to this, add to this. Once you finish this part, okay, add to here, add to so now 4 of how many I don't care. So all this thread will add their part to the sum, and eventually I got my results. See, interesting. Okay. If we don't have this, what happens? How you add each thread got this value to become the final sums, right? And this is the solution. You tell this is a critical section. Each thread will add this to this. Okay. Eventually you got the results. If we don't have this,
then your sum is 0.
There's a problem.
Yeah.
This is totally wrong. Okay. So now another way. You can this I said this is we call derivative. This part can be more complicated. So we call reduce or reduction. We want you can write like this instead of previously you needed 2 lines, right? Tell this critic want to add. This is too much. Okay. Is there any simple ways? Okay. Oh, sorry. We have simple ways. This is the part sum. I just want everyone calculate sum put together. How? Reduction. Tell this is parallel, and tell this parallel each thread. You should do reduction. And what the reduction? Reduction value is sum. Now, each process knows the sum, right? And sum do what of the reduction? You add. Okay? Which means thread 1 got sum 1, thread 2 got sum 2, sum 3. You should add those individual sum together. Okay? And eventually the sum will got the right value. Okay? You can use this code in your. You can test very easy to see it works or not. Okay? And you can assign like a simple like array. Okay?
Is it still parallel?
Parallel, it is parallel. It will become, if for example you have a 4 core, your 4 core will do this, and you will see 4 thread. Okay? Of course it's parallel. Because this is the first I will finish this. Okay? OpenMP is very great for parallel programming. And it is the simplest API to turn your code to become from serial to become a parallel. This is the very simplest way to do this. Okay? And interesting is here. Even you have those things, if your computer only one processor, then only one processor. Okay? Still. Okay? If you have more, it will more. If you even more processor, it will more. Right? Okay, and this is very easy. Okay, we have another way we call MPI. Okay, MPI is a language. Okay, it's a language based. It's on top of the C. Okay, you have a C language, and add those MPI, then you can use similar like OpenMP, but a little bit complicated than OpenMP, and to do the parallel. And this one is can do in the last 10 years or several years ago. Okay, the parallel computing will use this MPI. It's the interface, parallel interface. This should be multi-parallel processor or interface, something like that. Or messenger protocol processor interface. I don't remember this. Basically, this is tell different machine or different processor how they work together to do parallel. Okay? So this one is a little bit, you need more time to learning this language. Okay? And first we will try this. Okay? Easily to become a parallel. And later on, maybe next semester, if we have time, we can try this MPI. Okay? Also, MPI can run it on your machine. How? Your machine is only a few core, right? It's not a real. This MPI is supposed to thousands of computers can work together, build a network. They can work together, do a complicated calculation.
So our computer cannot.
Yes, we can simulate. Okay, how we have another program, simulator, install on your machine, and then your computer will simulate like more CPU, and then you can test this code. Okay? And that's normally what I teach some students to learn the parallel. I use this MPI and install a MPI simulator on your machine. It says like CHMPI or something. Yeah, I don't remember. It's an open source code and run it on install your machine. Your machine turns it to become a parallel machine. Okay. Okay. Now we'll switch to the second slide. a second slide. This slide is a little bit more information. Okay. This one is a little more OpenMP. Okay. So this we already know a little bit about the MP. Okay. So right now, parallel computer or parallel machines are abundant. Okay. The only thing how to use it. Okay. Many people don't know how to use technology of this multi-core. So most servers, your CPU is already a multi-core, dual core. Okay. So this slide is like 5 years ago we built this slide, and at that moment we saw processors will become multi-core, which is parallel programming. Okay, now it's a good time we're learning parallel to take advantage of this multi-core CPU. Okay, because some calculation, even your simple calculation, if you use multi-core, it will much faster, quicker. Okay, so now the third way is to take advantage of this. Okay, in the old days, we will teach you multi-threading. So when you some company hire software developer, say, and you need to know how to multi-thread. Okay, multi-threading, which means you need to create a thread and how to manage a different thread to do some kind of jobs. Okay?
What's the difference between multi-threading and parallel?
Parallel. Multi-threading is a parallel. The problem is here. Multi-threading, you create a multiple thread.
Yeah.
Each thread doing different job, right?
Yeah.
The problem is you need to manage this thread because they may cause some conflict.
Yes.
Okay? Both will access something, they will compete each other, maybe deadlock. Okay? It's easy to deadlock, very easy to deadlock. And your program is very hard to debug. Once your program becomes multi-threaded, especially in the server side, it's very hard to find some bugs because the program most of the time is okay. All of a sudden maybe stopped. And you don't know where it stopped.
If no phenomenon happens, it's usually dead. If flag.
Yeah. So it's the only problem is how to manage those. Okay. So, but anyway, we have some solution to if you create them. We still create some multi-thread. Okay. Because for example, I can create a couple of threads. One is for calculation. One is for graphics interface. One for the network. So you can create a couple of threads and do different jobs, then it's okay. Because they are not competing each other. But if you create a multiple thread, do some job like this, to calculate the same work each do part of it, they will compete each other. Okay, it's a little bit hard. Okay, and so multi-threading is a natural programming model for SMP. Okay, what is SMP? Okay, I will next slide. I will tell you what is SMP. Okay, SMP basically is this model. Okay, SMP is symmetric multiprocessing. Okay, this is basically currently our CPU is like this. Okay? You all have multi-cores. Okay? Each core have a unique cache with each process. They will share the main memory. Okay? They share this part. This is a symmetric multiprocessor. So this is SMP model. Okay? So this is SMP model. Okay? So this is basically it's easy to convert to become a multi-threaded because all the processors will share the same main memory. Okay? Because in this case they can share the data. Okay? So thread. So I don't know you know what the difference between thread and process. Okay? Thread in the process. Process is an instance of your code in the memory. Okay? One instance. Okay, it's running. And in this program, and they may have multiple threads. Okay, so thread is a little bit different between process. Okay? Threads can share the memory and processors no. Which means you two programs you started from Windows. They cannot share the memory because the memory is totally different. In the memory space, they totally assign different space. They cannot share the memory. But if it's a thread, okay, they can share memory because it's the same program. Okay, it takes advantage of the cores. Okay, they will share, so they will see each other. Okay, so in this case, they can easily work together to do some things. Otherwise, if two threads, then you need to talk to each other. We call message exchange. So that also has some technicals. For example, I have a thread here, it's a process, and another thread, okay, both running, and then how do they make in the same machine? How they communicate each other? Okay, we don't need like a network. You need a socket to talk each other. That's not good. Okay, so they have some message message. Okay, they will talk each other, use message exchange. Okay, some kind of message. Okay, they know. Okay, the signal that I have a message to you, so they can talk to each other. Okay, so.
Oh, they use weight and
But
signal.
Huh? Yes, this is another way to do it. Now, multi-threading still is very hard to build. Okay? If you use C programming in Linux, you use pthread to create a new thread.
Oh, no, that's good.
Okay, it's not good. It's, you need to manage those thread handle. And if we use Windows, the Windows also have some create thread. The thread is deadlock, as I said. The condition, the race condition. Yeah, condition. So sometimes it's very hard to debug. So this is the problem. Okay? That's why people created this OpenMP. It's a good smart idea. Okay. Now this is so we. Okay. This is tell you how to create a thread. Okay. So you use several different thread APIs. Okay. Windows we have a create thread function. Ask you to create a thread. Okay. In the Unix pthread. Okay, create thread. Okay. But still, it's not good because you sometimes you don't need this motivation. So
What's mutex in the last slide? I forget. Yes.
you don't know the mutex.
You
The
forget.
mutex. This mutex to protect access to some critical areas.
Oh.
Okay, because you need to check. Okay, if this is busy or not. Okay, if some other thread doing this part, this mutex, okay, other thread cannot access. If you access, you need to check this value. Is busy or not?
Oh, in Chinese 现成锁.
Yes.
Oh.
So you need to check is busy or is like free. You can enter this critical code.
Oh.
Okay. So this use mutex to protect the code. Okay, because if one thread go inside, it will lock. Lock, other thread coming, it will wait. You stop waiting. And then once you finish it, this will release and the other thread can enter. So use the mutex to protect the critical place or critical code, okay, to protect this access. Okay. So this normally the operating system doing this. Okay, operating system it will multiple thread, all this or process, so they work together. They need this mutex, okay. And then gradually this idea is going to your application. Your application can also use this good idea to write a good application program. Okay. So in a real program, definitely, if your code you want more efficient, more responsive, you need more thread, right? And this OpenMP, just part of the code, we can change it to multi-thread, and they make your code more efficient. Okay? But it's still not enough, because if you write a client-side code, you need a thread to handle the user enter something, right? And you need some calculation behind it. You still need to create a multiple thread and keep this thread all the time. So in this case, you still need, and even you still need this, and you can also at the same time use MP. It will create. If you go to that part, it will become a more thread. Finish it, stop. Okay. So still good. Okay. Now currently, this is OpenMP has become a standard. All those now it's supported by IBM, by Microsoft, by Intel, by HP, by Samsung. Many environments already
goes.
Yeah, some they are not building the hardware. Yeah. So there's no, at least they're not popular like some workstation, right? Yeah. Maybe out of business.
Oracle still have their system.
Do they have the hardware?
Oracle.
Still have?
Salary.
Still have, right?
Yeah.
Yeah, but not that popular. Not many people buy this.
Yes.
And this HP is still there, right? So IBM, of course, the big computer. IBM is, Microsoft means Microsoft provide the software, which means in their studio, Visual Studio, already have this. So if you open the Visual Studio, your project can run in this code. Okay? So that is good news.
But the SAN system is very stable.
The stable, yes.
Yes.
I used this when I was in pursue my PhD. I used Sun system. So once I finished, the Sun system replaced by the Windows. Okay. Because this is the old computer. Okay. So now also this one is available in Linux and also Windows. Okay, this is a compiler with Intel compiler available for Windows and Linux as well. So now here now we go back again. We have a main thread we call master thread. Okay, this is the only thread in your computer. Okay, you create a thread. So this is a fork, join, eventually this we call work thread. Okay, do some dirty job. Okay? So part is parallel, this we call parallel region. Okay, so this is OpenMP. Okay, this I already told you what this look like. Okay, and no, this is the same, right? Some like shell. Okay, this is the shell. So okay. Now this one we'll talk a little bit more about the OpenMP syntax. So how to use this? Okay, we have an OpenMP like a document. Hope I can find this document, then we can upload to the website. Not website, sorry, QQ. Okay, then you can download try this OpenMP. So mostly it's just a simple like syntax how to use it. Okay. So all this you need to include by omp.h head file, then all the code starting from this, and then remaining part is a little bit different. You call construct clause. Okay, you have many clauses. Okay, so this clause, construct clause, can tell this is the lower part, this part is a parallel region. Okay. So and the most important, you will sometimes we need synchronization, okay, which means you need to reduce, you need to synchronize. Okay, so we'll give some like examples. Okay, let me find out these examples. Okay. Now, for example, we have a function, right? Look, one is you use this primary constructor clause, and another one, this OpenMP also have lots of these functions. Okay? For example, this one will give you how many threads you created, right? Thread number, right? And also you can set the number, right? How many threads do we have? What this means? What is repeating several times? You can use this to distribute work between threads. Okay.
So you can set, for example, you know your 4 cores. The end is the
You can set 4 or you can set 2. You can choose differently. And now give you, okay. Okay, now another one is we call section. OpenMP section, okay. So this your code can divide it into 2 different sections, like a section. This is one section. This is another section, right? Okay, this is another section. Okay, and then
why they need to divide these? There's no point. There's just one is enough. Yeah, they all in the same. Yes.
yeah, I a little bit forgot what the section means, but sometimes you need the section. I mean,
Yes, because it's a sections, and then this section.
yeah,
I think they are
two different parts.
Yes, they can do at the same time.
Yeah. Yeah. This maybe use. This is not 4. Sometimes it's 4. then you can just one line, and it will automatically distribute the task. But if you use section, this is no for, you can also do it like this. Parallel section. This one part, this another part, maybe two work together, maybe. Okay. And now, this is interesting. Normally our code we call sequential code, right? Okay, semi-parallels. What does semi look like? Semi, for example, I will create a number of threads. Okay, this will get this number of threads, and if I know how many threads created, I just manually divide the task, starting from something to some end, and to this is what we call manually. You manually distribute the work for each thread. Okay, another way, this is not good. Okay, sometimes your code may be something wrong. It's better allow system to do this. Okay, because this tested many times. It's better to do like this. Okay, this one will automatically to distribute among this. It will normally will distribute evenly. Okay,
Normally
it's better than yours. Okay, you distribute maybe you divided this number, maybe you missed one. Okay, it's very easy to miss one because you divide something or it's not that good. Okay, for example, you have thousands of loop with thousand. So how many you should be first how many, second how many, so it's very hard. And this is already did for you. Why you want to schedule this? This is for schedule, static. Okay, so there are many, this part we call clouds. So many different kind of clouds. So you need a document to check OpenMP how many this you can use. Okay, right now I just give you some examples, but basically there are many. Here. If we don't have this, it's 5, which means this 4 is distributed, right? Okay, you can add something to make this work a little bit differently. Okay. Okay. For example, the 4. Okay, just the 4. Okay, this is a for loop we want to parallel. Okay, parallel. No, normally you don't need to change the code, okay? Which means that your parallel, you have an initialized value, then you have less than, greater than, less than, equal to, so doesn't matter. This operation is doesn't matter, comparison doesn't matter, the increment doesn't matter, okay? Basically, they can support any for statement, okay? This is just says doesn't matter, okay? And it will figure out how to distribute this work. Maybe a little bit complicated is here. So, for example, sometimes your for loop is not one variable. You have multiple variables. For I equal to something, j equal to something, and then I less than something, j greater than something, then I something, okay something. So you have 2 variables for your loop. For loop, I didn't try that one. Okay, you can test. Okay, hope it works. I'm not sure. Okay? Yeah, I never tried this because in the previous year I only tried for only one variable. Okay, for example, I only have this one variable, right? But basically here can multiple variables. I start 0, and j maybe start from 2, and this I less than or j you can use j compute same kind, and here you have 2 variables, right? So it makes things complicated to see what happens. Okay. I'm not sure it works, but it's supposed to work. Okay? Because this is the old standard. New standard, C99 new standard will allow this multiple. Okay? So if this new standard allows this, then suppose OpenMP also allows this. Okay? Because this is same environment, should be okay. Okay? We need to double check, right? I'm not sure. It says it doesn't matter. Okay? Basically, this is just one line to do this. Huh? So loading balancing, it automatically balances your work, okay? And well,
this is very difficult.
so your iteration calculates if all is the same speed, that's the optimal we want, because you have 4 or multiple processors do the same job, all finishing. That will save you time, right? If some processor finish earlier, some is late, then you have to wait the late, finish this, then you can do the next. So that's not good. So that's the little bit challenge, the load balance, because you use multiple threads doing the same job and distribute this job, right? Now four processes doing this, so we want everyone to finish almost at the same time. But sometimes it is a challenge. Okay?
It's really harder to.
Yeah, if you manually, it's very hard.
Yeah.
Thread communication.
For example, you add 1, 2, 3 to 100.
It's a little different, right?
1 and 2, and
It's
the 100 and 99 is the speed is not different. And you can't just ever.
So some maybe finish early, some maybe finish a little bit late. Okay, this is possible. Okay, it's always a different challenge. Okay. So how to make this we call.
Well, you have two strategies. One is polling, another is what?
No, here we don't need. So here we don't care.
Oh, okay.
It will wait.
Wait.
Oh.
They will automatically wait. Okay, so here how? Okay. It will wait. I mean, we call reduce. Okay, eventually you are gonna write answer. Okay, what is schedule? This schedule. Okay, scheduling something. This means this is default. It have a size. So we will mostly use a equivalent size, okay, to each thread. Okay. So if more chunks than thread, your data is more, you will use this round robin to each thread.
Oh, I forget this.
Maybe you forgot what round robin means. Okay, you take turns maybe to do this. Okay, you have 10 jobs, only 5 people do. Okay, so this 5 do this, and they switch and do the next 5, and it's like this.
Oh.
Round robin. Okay, so. Which means you have a 4. Now check now here you have a 4, right? And here you can say scheduling. Scheduling you can give a size, okay? And that size, if your size is 4, or you only have 2 processors, there is a problem, right? So you need a round robin. So to do this, if you have more, then it's okay. Okay? Or if you just shut up and don't tell anything, the system will figure out. Okay? Then you don't need. Okay, you don't tell how big you want. Okay? So this is scheduling. Static, dynamic is a little different. Okay? Static, the value is you give a value. Now we have an example somewhere. We have an example somewhere here. Schedule static.
Static means share.
Yes. Static. Let me see what this means. Okay. Should have static. Static is the size. If you give the size, then you tell. If you didn't tell the size, okay, you didn't tell the size, that's okay. You default, okay, it will default use equivalent size among different threads. Okay, you didn't tell, just static. Okay? You didn't tell the chunk size, it's fine. It will equivalent size to each thread. For example, you solid, but loop is solid loop. It will each one 500. You have the for I equal to 1, then I less than 1,000. So appropriate 1,000, right?
Yeah.
And divided each one, this one 0 to 500. That's one 500, 0 to 1 to 1,000.
Yeah.
Something like this.
And what's the differences of the efficiency between these three? What's our?
Now this is
Dynamic, of course.
This is we call, if you say dynamic, thread will receive chunk size dynamically.
Yeah.
But
Chunk size default is 1. Whoa. Default chunk size only 1.
This is yes, simple serial, not a parallel.
No, not a serial.
Default is
It will assign this dynamic. Maybe no, you do first, I do second. You do third, I do this.
Oh.
So like this. You remember?
How do choices from these three among these three?
3, they don't want to 3.
How do choices between static and dynamic and guided? Because if the processor will spend some time.
No,
to
they will
divide
need some time. They already know loop the like if we have 4 threads, okay, one is add 1, one is add 2, one is add 4, or 3, one is add 4. So it will add different.
Dynamic.
Yes. So yeah, I think it's they don't need to
I
calculate
think
every time.
there are 2 strategies.
Yeah.
One is you distribute, other
Yeah.
is called poly. You wait to see who is free.
Yeah.
You give. The
Yeah.
different. Yeah.
And another one is we call guided. Guided says start with large chunks.
Yeah.
Thread receive chunks dynamically. Chunk size reduces exponentially down to chunk size. So it's
It's just
this is just like strategy.
yeah, the strategy is different, but
Yeah.
actually, what's the difference is between
This 3.
these three?
You
yes.
can that good, but we can if we are interested, we can create a code. Try the 3 manual this time, and you know who is better. Yeah. So that's the research, you know,
Yeah.
how to use this and to do some simple research. Okay. Then you give some people some guide. So this one is better, and that one is not good. That's good research, you know. It's not a big paper, but it's some conference paper. No problem.
Yeah.
Especially in China, I should put in
Yeah.
conference should be okay.
Some
Because you told people how to use this OMP
conference.
smartly.
yeah.
You give some suggestions. That is your contribution. It's very good contribution. Not many people don't know this. Do some kind of they write a paper, and even not a big paper, but it's still worth right. Because
Yeah.
people read your paper, they know how to use this smartly, right? So it's good. You can compare this, then build some curves, and this is like this, right? So that's the reason. You can try different machine. This may be 4 processor, that's 8 processor to do same thing. What the difference? So you will get some conclusion, right? And yeah, that's a good research. Small project. That's true. Yeah, for college students, it's a good topic, you know. Okay. I also can do if, you see, parallel, you can do if with a expression to do, okay? And so many things. I will not go to detail to do all this, and just tell you how we have this, and how to use it. We need practice more, okay? And I will provide some now. This is a little bit more topic, okay? Because each thread may have some private data. Okay? So private data. So what data we are using? So for example, this is code, right? Or this is two code. So this is a int integer I don't have a value yet. So for private I, which means each processor will create an I for the cells. Okay? And the I value for one processor maybe I equal to 0, and the I less than 8, and I instead of add 1, add 2. Another one starting I equals 1, less than 8, something like I minus 1. Oh no, add 1, 1 add 2, 1 add 3, 1 add 4, for example. Jumping. Right? Starting different. So each one may have a private I. Okay, the value. Okay. And what this? Okay. Now, if you have this is I, you say for private I. This private, you don't need to say. Okay. If you don't say this, anyway, it will create a private I.
Yeah.
You don't need to say private I. Okay. The important is here. You have some value. Now, for example, this value you need to compare. Maybe this value. Okay. For example, this is IDX is for what?
Index.
I think this is IDX, so this is not I, right? Otherwise, there's no I. This is not right, right? Oh, the IDX is here. Okay. IDX equal to 1, X equal to 10. Then what this means? We want to do this part to parallel. First private X, okay. Last private is IDX. IDX. Okay.
I'm not so. I didn't understand.
This one, you know what the first primary means.
Yeah.
First private, right? the initial value is copied from the main copy.
What is
First the private,
what
which
is the
means
main copy?
when we start doing parallel, if you say this x is first private, then everyone will use 10, starting from 10.
Yeah.
Okay. This is copied from the main. This is the main. Okay. Go to here is parallel. What is the last private? Last value of the variable is copied to the main copy. But in this case, what is last private? IDX. Same for the
First,
last
the
value.
private maybe is start from this number, you do parallel.
But last and first in this case is the same. It didn't change it. The copy inside this part. Okay. Okay. Copy. No, always copy too. Okay.
So if I don't use the first or that's the private, the private, I just use the private. It
Yeah.
means is that means the I or the value will just used in this thread, not if this thread is finished, the variable is loose, disappeared.
Yes.
And if I use the first private or last private, this value can be remain.
Yes. Yes. I think so. I remember it's like this. And then it will return the value. Once you finish this, it will return because the x value maybe got changed. You see the IDX will got changed. Last private, which means whatever which is last value, I will got that value returned. This will first one got changed, I will use that value return. The starting is 10. I don't know if here got changed or not. If it's not changed, it's okay, right?
Yeah.
This is not changing. But if this IDX definitely got changed, right?
Yeah.
Because so whatever is last one, it will return. You will got this value will change.
What will happen if I don't use last private IDX? If I don't use this?
If you don't use, if you then which means you still keep this value.
Still keep.
Yes. Because this is local. Even you do this, it will lost. Okay? Because it's parallel, then it will lost. Well, in this case, we want to change this value. Then, if not parallel, what happens? If not parallel, this you want IDX equal to last, right? X, here X because it didn't change.
The
Last first is the same thing.
The last I, that data I equal X. Yeah.
So equal A minus 1, right? Up with, 1 equal to this.
Yes.
Yeah.
When the last equal one.
Yeah, last equal.
If the arrays have a lot of X.
Right? So that's why I add this. But if we didn't add, I think it's not a big deal.
Yeah, actually,
Right? It's not that big deal. Okay?
I don't think so.
Or you may not get the value.
Yeah, it will
You may
not
not
come
get the
out.
value. It may not come out.
When
It's
this
local.
finish,
Yeah,
it's still I.
Still I.
Still
You want.
one.
Yes. Still 1. So that's why this is you want return value.
But if I don't use the first private X, what will happen in the
You mean this one?
Yes, what will happen in the for loop? Because the for loop uses X and the index is 10, X is 10. If I don't use the X will be 0 or
No,
or
it's
still be
10. Still be 10.
still be 10. So the first private X is no need.
Because no one changed this.
It's not
so it should be
that,
okay. So it's not that it's optional.
Yeah, I think X is not.
Because we don't want to return this value.
Yeah, IDX is
Yeah.
changed.
Yeah.
Yeah,
Oh.
and if you want to return, so you
Yeah.
need the last number.
Yeah.
That is
So what is the function of the first private?
没有。
Okay. And we have more examples. For example, you have a data array, right? And we want this data array passed to the parallel. Now there are two ways. See, one is this array as a private. Each one is private data. Because another one, you want to copy this data. It's copied, so you can say copy. And this is for loop. So, okay. If like this, we already said this is critical information. And even you say last is doesn't work. It's not last. You want every thread add together. In this case, you say reduction. This is add. Add the sum together. Which this add means that I have a comma here. This means we want each thread calculate the sum and add together. You have 4 threads, 4 sums, and add together. We call reduction. If you search big data, map reduce, the reduce is this. Now, map means you want to distribute your job to many processes, and reduce means each one calculate the value and then you combine together. Reduce become one value. So map reduce. This is a reduction. Sometimes we saw reduce. Okay, and even in MPI also have a reduce. This is a reduce. So any associative operation must be used this. Okay? Maybe it's add, maybe it's minus, maybe it's like this, maybe or, maybe multiply, maybe divide. Anyway, so you should use this. Otherwise, your value is not right. Okay? Because each individual have a value, but they are not combined together. There is a problem, right? So, okay. Okay, what else?
Synchronization. Oh,
Which one?
this was.
Synchronization. Okay, you have 2 threads. Okay, and we don't want to interleave, so we want to work together, right? So, for example, you like this. You want this calculate this problem.
Yes. Maybe one thread is not.
This is only one thread. You want 2 threads to do this simple job, you don't have a problem, right?
Yeah.
So this is not good for parallel because only one job. X start from 0, and then 0 add 1 become 1, right?
Yeah.
If you 2 threads do this, no problem. Okay, it may be still 1, maybe become 2.
Yeah.
Okay, because you for 1, another one get this 1 add 1 become 2.
Yes.
So that's not good. Okay, this we call interleave. So the value is not we want. So it's not good. Okay, because it's interleaving. Okay.
Yes.
So you need to know this limit. So multi-threading, some part you need a multi-thread, some part maybe you don't want multi-thread. Okay. Okay. And several interesting topics here. Sometimes if you do something parallel and then become a serial. Okay, some critical stuff. Sometimes we need a barrier. This is just a statement. This barrier means thread finish first should stop there. Don't go. Okay. Waiting for other thread finish. When it's finished, always finish it. Then go on to the next. So we have a barrier. Okay, this we call synchronization mechanism. Okay. So they also now have some no wait, which means you don't want to wait. Okay. Okay. So reduction, you see the reduce is similar like a barrier. Okay. Reduce, this is reduce here. Not just reduce, it says everyone should finish and then do this calculation. The wait, this may be first to finish, right? So, get together. Okay. 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 Do we have a reduce some kind of? Okay. Also have like single master. Okay. What this means? Oh, okay. Sometimes you say I want one processor do this following job. You say you just write this. Okay? You create a multiple thread, parallel. But this part, now the whole part is parallel. This is parallel, but this part is input. I want this part single. Only assign one processor to this part. Okay, this part I want master thread to do this.
Oh.
Okay, this is what we call single or master. What this means?
Master is using.
Yeah, master is is a main thread. Okay, And single, any thread can do this job.
Yeah.
Okay, whatever is free,
Yeah.
first finish this part and assign it to you and do this input. And master will do this part. And the remaining is multiple again. Yeah.
What's the difference between the master and the single?
single 每个任何
Any thread can do.
但是 master 肯定是那个去分配监护线程的那个
Main thread.
Main
thread. Yeah. This,
Any
I think it's not that critically important. Okay, you can say this is
Yeah.
single. It's not, they can do the same job.